The James Webb Space Telescope has captured an image of a galaxy called GLAD Zeta 13, which has broken the record as the oldest galaxy ever observed by astronomers. This galaxy formed approximately 300 million years after the Big Bang, since it began operations on July 11. The telescope has amazed scientists with its clear images and fascinating discoveries. These findings include the detection of an exoplanet with the right conditions to support life, as well as an image that spans 1/5 the diameter of the Moon and shows us Jupiter's rings in greater detail than ever before. What exactly does this image provided by the James Webb Space Telescope represent? What will this impact on our cosmological research as we know it? Stay with us until the end to learn all the details about this latest shocking revelation. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell. The James Webb Space Telescope has many advantages over the Hubble telescope. For example, the James Webb is located at a distance of about 1.5 million kilometers from Earth, 4 times farther than the Moon. This means that there is no interference from space stations or satellites that could affect the images obtained by the telescope. On the other hand, Hubble is only 547 kilometers from the Earth and can observe mainly in the visible and ultraviolet bands. In addition, the James Webb is equipped with NIRCam for the near-infrared and MIRI-Cam for the mid-infrared spectrum, while Hubble does not have these tools. This makes the telescope so powerful that it could even detect a bumblebee fluttering in space at the distance between the Earth and the Moon. The JW's infrared vision also allows it to observe the edge of the universe, where galaxies and older stars are found that might otherwise go undetected. The Hubble Space Telescope has limitation in its ability to see beyond the veil of gas and dust that surrounds planets, stars, and galaxies. In contrast, the James Webb Space Telescope is able to do this with ease, as if it had an X-ray beam. One of the main differences lies in the size of the James Webb mirror, which measures 65 meters in diameter, allowing it to absorb much more light than Hubble. In fact, this is the largest mirror ever sent into space and nearly 3 times larger than Hubble's 25-meter mirror. Thanks to this unique technology, the first images obtained by the James Webb Telescope were surprisingly clear. Even faintly luminous objects were visible. In fact, the deepest and clearest image of the early universe to date was captured by the James Webb in a single day, while Hubble took several weeks to collect similar images. The deep field image captured by the most expensive telescope in history shows thousands of galaxies, demonstrating its superior ability to explore space. At the center of the image is a group of galaxies that make up a cluster called SMACS 0723, whose collective mass acts as gravitational lens that bends the light from more distant galaxies behind it, causing it to warp. The James Webb Telescope has been able to detect many galaxies that have never been seen before by any other telescope. The James Webb's starting point was our solar system, where it captured the image of Jupiter while it was in the testing phase. Since then, the telescope has taken numerous images of the gas giant, demonstrating its exceptional capability. The images clearly show the planet's famous stripes, which are the result of complex atmospheric phenomena, as well as the Great Red Spot, a giant storm 16,000 kilometers wide, large enough to engulf the entire Earth. Jupiter's satellite, Europa, can also be seen in the image, as well as other moons. The James Webb Telescope also managed to capture images of Jupiter's rings, which is an incredible achievement because they are so faint and difficult to distinguish near bright objects in space, including the planet itself. The telescope then turned its attention to the exoplanet WASP 96b, which is at a very far distance from us, and managed to obtain surprising results. Scientists discovered that it is a gas giant with a mass less than half that of Jupiter, but with a diameter 12 times larger. The exoplanet is as puffy as cotton candy and revolves around its star much closer than Mercury does to the Sun, heating it to more than 1000 degrees Celsius. JWST recorded the presence of clouds and haze in the planet's atmosphere and detected traces of water indicated by certain gas molecules present in its atmosphere. Scientists were very pleased with this valuable discovery, especially after the Hubble Space Telescope searched for water for the past 2 decades and was only able to detect it in 2013. This is intriguing, but not as exciting as finding extraterrestrial life forms on WASP 96b. The discovery of biologically significant substances such as water, oxygen, carbon dioxide, and methane is a first step on this path. If these substances are found on rocky planets, it will be a clear signal to start looking for signs of life there. Another image captured by the JWST shows the Southern Ring Nebula, which is 2,500 light-years from Earth. This nebula surrounds a dying star, and it is composed of at least 8 layers of gas and dust that have been ejected by the lower star. The bright central star mixes these emissions to create complex rings of planetary nebulae, similar to how sunlight on Earth illuminates the gaps in clouds. Previously, the Hubble telescope had captured stunning images of the Southern Ring and many other nebulae, allowing us to see that these are not simply clouds of gas, but complex and colorful systems. However, the James Webb has done an even better job of providing an even more detailed image of the planetary nebula, as well as a much broader view of the space behind it, which is filled with many galaxies. Compared to the Hubble image, the James Webb image is much more detailed, and the bright stars in the Hubble image have 4 rays, while the stars in the JWST image have 6 points of light. This is because Hubble has round lens with a secondary mirror hanging in front of it in 4 extensions, while the JWST lens is composed of 18 hexagonal mirror segments. Now, take a look at the stunning image of the purple milestone, that is the spiral galaxy NGC 628, also known as M74, located in the constellation Pisces, about 32 million light-years away from Earth. Why is this image so different from the Hubble image of the same galaxy? The reason is that the James Webb Telescope had a different task: to make a detailed analysis of the threads of dust and gas that block the light from most stars, allowing us to see the aftermath of supernova explosions and star formation zones, which makes the image more dynamic. But let's not stop there. Let's take a look at another impressive image. It is the largest image taken by the JWST and covers about 1/5 the diameter of the Moon. It shows a compact group of galaxies known as Stephan's Quintet in the constellation Pegasus, about 290 million years away from us. The image of Stephan's Quintet captured by the legendary James Webb Telescope shows 4 of the 5 galaxies approaching, colliding, and dancing together in a gravitational dance, while the 5th galaxy observes at a distance of 40 million light-years from Earth. Although the Hubble telescope has also allowed us to admire Stephan's Quintet, the James Webb image offers new detail and was created from nearly 1,000 separate images, totaling more than 150 million pixels. The image reveals bright spots of distant galaxies in the background, as well as entire regions of star formation, and broad tails of gas and dust and stars ejected from various galaxies due to gravitational interactions. Huge shockwaves can also be seen as the galaxy NGC 7318b passes through the cluster. The galaxy NGC 7319 has an active supermassive black hole at its core, and the James Webb Telescope was able to see beyond the dense layer of gas and dust at the center of the galaxy. The telescope discovered hot gas near the black hole in great detail. In addition, the image of the cosmic cliffs revealed a young star forming region called NGC 3324 in the Carina Nebula. Intense ultraviolet light and stellar winds from extremely massive young stars have sculpted the wall of the nebula. Experts were once again surprised when comparing the Hubble and James Webb's images. The image produced by the JWST is much clearer, which is especially noticeable when superimposing the images from both telescopes. In the image, you can see bright spots in the background, not only stars, but also very distant galaxies. The blue haze that appears to emerge from celestial mountains is actually hot ionized gas and dust ejected from the nebula by the continuous radiation from the young stars. If you've seen these amazing images, which is your favorite? Give us a like and have your say in the comments. The James Webb Space Telescope has just begun its cosmic mission, so be sure to stay tuned for new videos. Subscribe so you don't miss a thing. Thanks so much for watching, and I'll see you in the next one.